Hello, everyone, and welcome back to the class. We are now entering week 3 of the course, and we are going to cover chemical reactions. A chemical reaction, loosely put, is taking a couple reactants and putting them together to cause an effect and then produce a product. In the last class, we learned about bonding, varieties of different bonding, and how the elements bond together to start to form molecules, which allow us to bridge the gap between a concept, a scientific concept, a hypothesis, a theory, into something a little bit more physical, something we can see and that's tangible. A common chemical reaction can be done using everyday products. I actually have a demonstration I want to show you that shows you a basic chemical reaction. So this chemical reaction, we are going to use everyday products such as this Diet Coke. And then we're going to put some Mentos in it. Now, what's going to happen is that these Mentos have an active ingredient that when it combines with the acidity and the carbonation found in the soda, it will cause a chain reaction. And what it's doing is it's bonding together all the different properties or different chemical elements that are found within the soda that have already bonded together to, provide things such as the acidity and the flavoring of this Coke. So let's open this up real quick. So we can think of as the Coke as a reactant, the Mento as a reactant, and then what is going to be left over after this experiment has been completed would be the product. So let's drop the Mentos in. See on how it's fizzing and bringing up to the surface? That is a chemical reaction. And it's a pretty cool one. You can do this at your own around your own house without having to have complex lab. So I am going to now segue into our next topic, and that is going to be talking about acids and bases. Acids and bases are solutions that we come into contact with during our day-to-day lives. They're compounds after the bonding. And we need to be able to conceptually understand acids and bases in relation to the pH scale. The pH scale, and we'll talk more about this in lecture, is a metric that we use to assign if a solution is acidic or is it basic. Numbers that are less than 7 are acidic, greater than 7, basic. Water is neutral, meaning it has a pH of 7. And in your lab assignment this week, you will be using a simulator that will show you how we can go about balancing acids. So right here, I've got a beaker experiment again, where you're going to have a beaker. We are going to have some 1 molar hydrochloric acid, and then Alka-Seltzer. Now, Alka-Seltzer, we typically take this, we put it in water as a way to relieve acid indigestion, upset stomach, heartburn, headaches, body aches, and pains. Hydrochloric acid at 1 molar is the same strength as, say, table vinegar. So what we're trying to do is take an acid and then get it to react with a base. So I'm going to put in some acid into this beaker. Now, when we want to be able to test the strength of the hydrochloric acid, we'll use a sensor. I'll just put it in just to verify the strength of the 1 molar hydrochloric acid. The sensor is telling me that it's about 2 to 2.5, and at the low number of 3. So this is a very acidic solution. Take the Alka-Seltzer, spit it up. And so what now we're gonna take the Alka-Seltzer tablet, put it into the acid. That is gonna cause a double display replacement photon reaction. But really, we just want to make sure that the base causes the acid to fizz and become neutralized. So you ready? 3, 2, 1, go. Notice on how it's fizzing reaction. Well, what's going on is that molecule-wise, the base is going in and breaking the bonds that cause that hydrochloric acid to be, well, hydrochloric acid. It's removing them and separating them into their smaller components. If we test it by putting our sensor back in, the pH has actually risen. It's no longer at the most 3 on the pH scale. It's actually getting closer to 7. So it's converting that hydrochloric acid with a reaction and further neutralize it by adding water to it. We can get water and pour it directly in, which will break down the salts even further. Seeing that water has a pH of 7, we can put the sensor in. And now the number is sitting right close to around 6 to 7. So this tells us that we can actually control these different reactions. And that's going to be your goal in lab this week. If any questions, feel free to reach out. And I'll also have a small lecture that just quickly runs through conceptually what the pH scale is and its relationship between acids and bases.